Welcome back. This is part 2 of Intro to Function Notation. We're going to start with example 2, and this is going to jump right into some new concepts. This f of a plus h minus f of a all over h is a particular type of function composition where we use this formula for the difference quotient. And it's basically showing the slope of a line between 2 points. Now, I'm not going to go into too much detail on that, but I do want you to understand what we're doing. This is two separate function substitutions, all divided by h. So we're going to start out with the f of a plus h. We know that our original function rule is an x cubed. But instead of x substitution, we're going to substitute a plus h into our function. So our input, or domain values, are a plus h. So that is what I will substitute in place of the x. This is kind of a big process. However, you can expand it using Pascal's triangle. Go ahead and Google that if you want to see more on how to do that. I'm going to have an a cubed. I know I'm going to have an a cubed, and I know I'm going to have an h cubed. So now I need to figure out what I'm going to have in the middle. I'm going to have plus 3a squared h plus 3ah squared plus h cubed. Go ahead and look that up if you're confused on how I got that. I'm not going to FOIL that out here on the video. It's just going to be too time consuming. But that is what I get. So now I'm going to find f of a. So now a is my input or my domain. And so wherever there was an x in the original function, I'm substituting an a in its place. And that just gives me an a cubed. Now notice that I am subtracting the f of a from the f of a plus h. I will go ahead and do that here so you can see what that looks like. I have a cubed plus 3a squared h plus 3ah squared plus h cubed minus or subtract a cubed. And then I need to divide the whole thing by h. That's this last part right here. Divide by h. Well, I know that my a cubes add to 0. And that's going to leave me the remaining portion here, 3a squared h plus 3ah squared plus h cubed all over h. And notice that my numerator has an h in every single term. Well, I can just go ahead and factor that h out front. That will give me a 3a squared plus 3ah plus h squared. And if you're curious how I got that, well, just go ahead and multiply that h back in, and it will be exactly like what I started with in the numerator. That's all over h, and conveniently, my h's divide out. This means that my final answer is simply the numerator, 3a squared plus 3ah plus h squared. Let's take a look at f of x equals 3x squared plus 1. We again need to find f of a plus h minus f of a all over h. So I will find f of a plus h first. a plus h is my input. 3 times a plus h squared plus 1 will be what I get when I substitute that input in. Simplifying will give me 3 times a squared plus 2ah plus h squared plus 1. Rewriting, distributing the 3 through will give me 3a squared plus 6ah plus 3h squared plus 1. Now let's find f of a. A is my input. That will give me 3 times a squared plus 1. Now let's find f of a plus h minus f of a all over h. By color coding, I need to put f of a plus h first and subtract f of a from it. This will give me 3a squared plus 6ah plus 3h squared plus 1 minus the quantity, because if you subtract something it's going to change all the signs, 3a squared plus 1 all over h. Distributing the negative, I will have 3a squared plus 6ah plus 3h squared plus 1 minus 3a squared minus 1. My 3a squareds add to 0, and my 1's add to 0. This is still all over h. And notice that all the terms that are left have an h in them. So now I have 6ah plus 3h squared all over h. Dividing out the h, as I did in the previous problem, or factoring it out front, will give me 6a plus 3h all over h. And my h's will divide out. And my numerator is what's left. Now I just want you to notice that this is going to happen every time when we're working with this difference quotient. It's a consistent pattern, so once you see it a few times, the pattern keeps repeating. Let's give f of x equals x squared minus 5x plus 4 a try. F of a plus h will give me a plus h squared minus 5 times a plus h plus 4. And f of a will be a squared minus 5a plus 4. We need to find f of a plus h minus f of a all over h. If I simplify f of a plus h, I will have an a squared plus 2ah plus h squared minus 5a minus 5h plus 4. And then I need to subtract f of a. That will give me minus a squared plus 5a minus 4. That's because remember, I'm distributing that negative sign through. This one right here, right in front of the f of a. This is all over h. And now I just combine like terms in the numerator. This can get a little bit hairy because there's so many terms sometimes, but there is a pattern. So the a squared and the negative a squared add to 0. The 4 and the negative 4 add to 0. The negative 5a and the positive 5a add to 0. Notice that everything that's left is an h, so the pattern still holds. This will give me 2ah plus h squared minus 5h all over h. Factor out the h in the numerator and you get 2a plus h minus 5 all over h. Divide out the h's. Your final answer is what's in parentheses, which is 2a plus h minus 5.